Hello everyone, and welcome to the next video in the series. In this video we'll take up the topic of direct proportion, and I will also apply the methodologies that we use to solve direct proportion problems to everyday life problems. In the next few videos we will apply the techniques and approaches to solving direct proportion problems to other kinds of problems, such as problems that involve conversion of units, working with chemical reactions, and also percentage problems or certain kinds of percent problems. Okay, so direct proportion basically involves two quantities that are related in such a way that multiplying the value of one of them by a number implies that the value of the other gets multiplied by the same number. Or you could divide the values of both of the quantities by the same number. So basically, if one doubles up, the other one doubles up. If one gets divided by 4, the other one gets divided by 4. And of course, these multiplications and divisions have to work for all numbers. To give you an example of a problem that's direct proportion, let's take a look at problem number 1. This problem says 1 pen costs $5. At this rate, what amount of money did I spend if I bought 2 pens? The two quantities in this problem are the number of pens and the cost of the pens. And these are related through direct proportion. And again, what this means is that if you buy twice as many pens, you pay twice as much. If you buy 3 times as many pens, you pay 3 times as much. And of course, if you buy half as many pens, you pay half as much. So this is the kind of relationship that we call direct proportion. The value of one of the quantities gets multiplied or divided by a number, and the value of the other quantity gets multiplied and divided by the same number. Okay, so if you have that kind of relationship, then there is a way to go about solving these problems. There are actually multiple ways of solving these kinds of problems. But one way that I will be presenting here, and I will also allude to the other approach, to at least one other common approach, but the approach that I would like to make popular is the one that uses unit rates. It's one of the easiest to set up, and unlike the conservation form of the equation for direct proportion, it can be chained. So it's a very powerful kind of an approach, and it's also very, very efficient. Okay, so to explain how we go about solving the problem that we had, and let me actually bring this back. Problem number 1. We begin by noting the unknown, which is the amount of money that I spent on the pens in dollars, and we use the letter A to represent its value with. Okay, so what I'll do now is I'll show you how to go about putting together an equation that solves this problem, and then I will explain how it is that it works. So initially your focus should be on how to set it up without wondering about, oh, that sounds like magic. And then once you know how to set it up, I will explain why it is that it works. And to begin, we always take a look at the problems that we have, and the information that's given in the problem that we have, and try to find the relationship between the two quantities. This relationship, the one that I'm talking about, is the fact that the problem says 1 pen costs $5. So in some sense, these two values are related, and we make a note of that. Here we have it. So 1 pen costs $5. And then if we have one relationship like this, then our equation will look like this. There will be one division and then multiplied by a number. If you have multiple relationships, sometimes we have 2 such relationships, or 3 of them, or more of them, then for each relationship we will get one division. And in fact, the numbers in the relationships that we have will go on top and the bottom of the division. Okay, so we have one relationship, and therefore we will have one division multiplied by a number. Now, in sequence, I will show you how to put the numbers in, and we begin with the one that comes after the times. And this is the number that we want to work out. We want to find the amount of money that we spent on 2 pens. And so we put the 2 pens here. Okay, Now, normally we don't put the units in, but in the case of direct proportion problems, you'll find that this can actually help a lot in setting up the equation. And also when we have multiple relationships, then it becomes really tough to keep track of what has been used and what should go where. But if you put the units down, that makes it a lot easier. Later, of course, if you don't like them, you can always drop them and just keep the numbers. Okay, so 2 pence. And then to decide, as I said, that these two numbers that are related, they will go on the top and the bottom of the division. To decide which one goes where, we take a look at the unit that we have here, that's pence. And we will match that unit down here. So now if I go back to the relationship, I see that the unit of 1 pen is pen, and the unit of $5 is dollars. And therefore we put down 1 pen down here, and we put $5 on top. Okay, now once you use a relationship, you may want to check it off. This may not be that important if you have only one relationship, but as you will find out when we have multiple relationships, it becomes again difficult to keep track of what has been used and what has not been used, especially because they're not always placed in order from top to bottom. And therefore it becomes confusing after a while to decide where the rest of the numbers go, and so we check it off. Now this is the setup then, and this will solve the problem. We have 2 pence, and then we match the unit pence, and we put the dollars on top. And if you think about it, the reason that this setup works, now the green is something you don't have to really write down. But it explains how things work. And here we notice that if we divide 5 by 1, of course we get 5. And this is how many dollars we pay for 1 pen, so that we can say per pen. So it's really $5 per pen. And then if you buy 2 pens, you, I think, understand that you need to multiply the two of them to find the total cost. So if we multiply $5 per pen by 2 pens, we find the total cost, which is $10. Now, this logic is it's very interesting that this logic is the only logic that you need to work with all direct proportion problems, at least following this particular kind of an approach. Now I would like to emphasize that the green is something that we don't have to write down, and normally we skip that stage but if you wanted to explain to someone, let's say, how things work, then it would be a good idea to keep the text in green. Okay, so let me get rid of the green, and here you have it. So this is the way it should look. All right. Now to work this out, you can always divide 5 by 1 and then multiply by 2, or you can multiply 5 by 2 and then divide by 1. Okay, so this was an easy problem, of course. However, I would like to, in the context of this very easy problem, I would like to also present the alternative approach. One alternative approach that's very common is to start the modeling by putting down what we call a proportion equation in conservation form. And in this kind of setup, we associate the top to one of the quantities involved, such as number of pence or dollars, and we associate the bottom to the other quantity. So if the top is the number of pence, then the bottom will be dollars, and vice versa. If you choose to put dollars on top, then at the bottom will be number of pence. Either way, it will work out to the same solution in the end. Okay, so now what we do is we start with the relationship that's given, and we put down, let's say, pence on top, dollars down. So our next step is to put down 1 pen, and then down here we put down $5. And now the top is the number of pence, and the bottom is the number of is the amount of money that we spend in dollars. Now the other number that you want to work out, the 2 pence, will go on top on the same side as pence. The top is the number of pence, so we put 2 pence on top, and we put A for amount of money that I spent down here. So the ratio of 1 to 5 should be the same as the ratio of 2 to A. That's the kind of logic that goes into this kind of setup. Okay, to solve this problem, I'm sure many of you have seen the crisscross approach, and we can use it here. Later on, I will explain that the reason it works is because division on one side becomes multiplication on the other side. So division by $5 on this side becomes multiplication on the right side. It will multiply 2 pence. And division by A on this side will turn into multiplication on the left side, and it will multiply 1 pen. And so if we take the crisscross approach, then we end up with 1 times A is equal to 5 times 2. And on the left side, we end up with A, and on the right side with 10. And so I spent $10 on the pens. Okay, so for one-step problems, it seems like they're both pretty much the same, have the same level of efficiency, although if you leave out the green line, then the top approach will be more efficient. But what you'll find out is that as we step from one proportion problems where we have only one relationship to multiple proportion problems where there are multiple relationships, that this approach really works very well, and in fact it doesn't grow in terms of the number of lines that you have to write down, whereas the alternative down here will become pretty time consuming and long to write. You will see some of these examples coming up later on in this video, and also in the future videos I will show you that the alternative down here again becomes very long, very time consuming to work through. Alright, so now this was problem number 1. Let's move to problem number 2. This problem says that 3 pence cost $15. At this rate, what amount of money did I spend if I bought 2 pence? Now this is similar to the previous problem. We are looking for the amount of money that I spent on the pens, and we notice that there is only one relationship here. 3 pence are related to $15. We make note of that, and therefore because there is only one relationship in our equation, we will have one division. The numbers in the relationship as usual will go on top and bottom of this division. Now we begin with what comes after the times, and it's the number that we want to work out, the 2 pence. We want to find the amount of money that we spent on 2 pence, and we write it after the times, and this gives us the equation A equals sum division times 2 pence. And now again the numbers in the relationship, 3 pence and $15, will go on top and bottom of the division here. And to figure out which one goes where, we use the unit pence and match it down here. So 3 pence goes down and $15 goes on top. Okay, let's now check off the relationship. Now again you would multiply or you would divide 15 by 3 and then multiply the result by 2 and then write the final answer down. If you wanted to explain to someone or to yourself, if you want to remind yourself as to how it is that this works, then you would have to divide first. You would have to argue that $15 for 3 pence would translate into $5 per pen. You divide 15 by 3 and that gives you how many dollars for 1 pen per pen, and then you multiply by 2 pence, and so I spent $10 on the pens. Okay. Now the next problem, problem 3 says 4 pence cost $12.40. At this rate, what is the cost of buying 5 more pens? So for an algebraic solution, once again we note that C is the cost of the pens in dollars. And in this case, again, one relationship is given to us, 4 pence, $12.40. We make note of that. And therefore, because there is only one relationship, our equation will have one division multiplied by some number that follows. The number that follows the multiplication sign is the one we want to work out, the 5 pence. And the numbers on the top and the bottom of the division will come from the relationship 4 pence, $12.40. We match the unit down here, so 4 pence goes down and $12.40 goes on top. Now again, if you want to explain how it works, you perform the division to find the cost for 1 pen. So if it's $12.40 for 4 pence, you can divide $12.40 by 4 to find the cost of 1 pen, which is $3.10 per pen. And then we multiply this by 5 pence, and we end up with $15.50. So the pens cost $15.50. Right, don't forget to check off your relationship, especially in case you have more than one. Again, with one, once you use it, it's done and you don't have to worry about it. But with more than one, we need to keep track of what has been used and what has not been used, because some of the units repeat, and then it becomes difficult to match the unit as you build your chain. All right, next problem. Now let's move away from money problems and talk about some other kinds of problems. This one says 4.1 liters of a solution has a mass of 5.2 kilograms. At this rate, what is the mass of 2.3 liters of this solution? Okay, so for this problem, let me bring it back. There we go. So for this problem, what we are seeking is mass, and therefore we use the letter M to represent its value with. And the unit used is kilograms. Now one relationship is given to us, 4.1 liters and 5.2 kilograms, and therefore our equation will look like this. There will be one division and then multiplied by the number that we want to work out, which is 2.3 liters. We put 2.3 liters here after the times, and then we match the unit down here, so we put 4.1 liters down and 5.2 kilograms goes on top. Now again, you can divide 5.2 by 4.1 and then multiply the result by 2.3 and finish the problem. However, if you wanted to remind yourself as to how it is that it works, then you would perform the division here. 5.2 divided by 4.1 will tell you how many kilograms per liter. Very similar to the money problem that we just talked about. So the division gives me about 1.27 kilograms per liter of the solution. And then because 1 liter has a mass of 1.2 kilograms, to find the mass of 2.3 liters, we multiply. And we end up with 2.92 kilograms. So the solution has a mass of 2.92 kilograms. I would like to mention once again that the green text is something that you would write down if you wanted to explain to yourself or remind yourself as to how it is that this works. Otherwise, you would not write it down, and your solution would be shorter in that way. Your solution would look like only that much. So there will be an opening statement, the equation, the final answer, and the closing statement. As far as the unit goes, you notice that the liters cancel out here and here. Cancellation in this sense is very similar. Cancellation of units is very similar to cancellation of numbers or reduction of numbers that we will see with rational numbers later on. Okay. Now next problem, we have 4.1 liters of a solution has a mass of 5.2 kilograms. At this rate, what is the volume of 7.7 kilograms of this solution? Now the previous problem, it gave us the volume and asked for mass, and the present problem gives us the mass and asks us to find the volume. Okay, so an algebraic solution for this problem, we're going to use capital V for volume of the solution in liters. And again, because one relationship is given to us, 4.1 liters and 5.2 kilograms, there will be only one division over here. And that's multiplied by the number that we want to work out, 7.7 kilograms. Now we match the unit down here, and we put 5.2 kilograms down here, and 4.1 liters goes on top. Okay, we'll check off the equation or the relationship. And as usual, to explain how it works, you can divide 4.1 by 5.2 and you get about 0.79 liters per kilogram. And if you multiply this by 7.7 kilograms, you'll find the volume of the solution, which is 6.1 liters. Again, kilograms cancel out and we'll be left with the unit liter. And therefore the solution has a volume of 6.1 liters. Now all of these problems have been the kinds of problems where we had only one relationship. Here comes a problem where there are two relationships that are given. This problem says 4.1 liters of a solution has a mass of 5.2 kilograms. 4.5 kilograms of the solution costs $8.20. At these rates, what is the cost of 5.5 liters of the solution? So there are two relationships that are given right now. 4.1 liters relates to 5.2 kilograms, and 4.5 kilograms relates to $8.20. Okay, we start our solution then. What we are seeking is the cost of the solution in dollars, and we use lowercase c to represent its value with. Now, we notice that we have two relationships, as I just mentioned. One of them is 4.1 liters and 5.2 kilograms, and the second relationship is 4.5 kilograms and the cost of $8.20. And therefore, our equation will have two divisions, and this will be the format. One division here, one over here. And the numbers in one relationship will go on top and bottom of one of these divisions, and the numbers in the other relationship will go on the top and the bottom of the other division. We begin with the value that we want to work out, 5.5 liters. And so we write 5.5 liters. Now, here we need to match the unit liters down here. And if you take a look at your relationships, only one of them has the unit liter. So there is no way to go wrong. We pick the numbers in this relationship. 4.1 liters goes down here, and 5.2 kilograms goes on top. And so we write down 4.1 liters and 5.2 kilograms. Now, if I was going to work out this piece, I would find the mass of the solution in kilograms. The liters would cancel out, and the unit would be kilograms. Now, this is an example of where it's a good idea to check off the relationship that you use. Let me try to continue without checking off the relationship that I just used, the 4.1 liters and 5.2 kilograms. Now, once you match the unit liters and liters, you'll be left with kilograms. And now you match the unit kilograms down here. But if I go back to my relationships, I notice that both of them have kilograms. And now I am not quite sure which one I need to use. However, if I check off the equation that I used, or the relationship that I used, this one, if I check it off, for the next division, when I go back to match the unit kilograms, I notice that there is only one option left. The top relationship has already been used, and it should not be used again. So now we understand that 4.5 kilograms goes down here, and $8.20 goes on top. And now we check off the second equation. Now all equations have been used, and we are done with the model or the equation over here. Okay, now you can divide 8.2 by 4.5, multiply by 5.2, divide by 4.1, and then multiply by 5.5, and find the answer in one step and finish it. Let me show you how it works out on the calculator. It's actually not a bad exercise to see this. So here we start with 8.2, and then divide by 4.5. So we hit divide by 4.5. Now there is no need to hit equals. Then times, and then we put down 5.2, 5.2. Again, there is no need to say equals until the end. Then divide by 4.1. So divide by 4.1, and then multiply by 5.5. Multiply by 5.5. And now you say equals. And so it's about $12.7. As far as the unit goes, liters cancel out, kilograms cancel out, and the final unit will be dollars. So $12.71. Okay, let me clear this. Now that's what you would do, and you would write down C equals $12.71. If you, however, wanted to explain to yourself how it is that this setup works, then you would have to perform the division here and perform the division here. The first one would tell you how many dollars per kilogram. The second one would tell you how many kilograms per liter. And we would arrive at $1.82 per kilogram, 1.27 kilograms per liter, and then 5.5 liters. Now, in order to explain how it is that this setup works, we decode from right going back. And in fact, we multiply 1.27 liters kilograms per liter by 5.5 liters. Because I know the mass of 1 liter, if I multiply by 5.5 liters, I find the total mass. So working out this piece will give me 6.99 kilograms. And here you have it. Now I would like to mention that this is actually very, very similar to what we had with the money problem. So with the money problem, we had, let's say we had something like $3.10, and let's say that this was per pen. And if we now multiplied this by, let's say, 5 pence, then we would find the total cost, which is $15.50. You notice that if I know dollars per pen for 1 pen, then it makes sense for me to multiply by 5 pence to find the total cost. And same logic over here. If you know how many kilograms per liter for 1 liter, then you can multiply by the volume in liters to find the total mass. So it's the same logic that keeps repeating. In fact, it keeps repeating at the next stage. Once we take this step, we find how many kilograms, and then once we take the next step, we find how many dollars. And for the next step, again, you notice it's the same kind of logic. Just like so many dollars per pen times the number of pens makes sense, so many dollars per kilogram times the mass in kilograms also makes sense, based on pretty much the same kind of logic. Okay, let me remove what I just added down here. And therefore, we multiply 1.27 kilograms per liter times 5.5 liters to find the mass in kilograms. And then we multiply so many dollars per kilogram by the mass in kilograms to find the total cost, which is $12.71. And therefore, I can say that the solution costs $12.71. Now, once again, none of the green text will be displayed. That again is usually for your own understanding, and normally what we do is we don't bother writing them down. And if we do that, then our solution will be much shorter, and it would in fact look like the following. Just increase the spacing a bit. There we go. And so here's the full solution then. C is the cost of the solution in dollars. Because there are two relationships, we will have two divisions. Begin with the number that you want to work out. Now from the relationships, match the unit liters down here. There is only one option. 4.1 liters goes down. 5.2 kilograms goes on top. And then match the unit kilograms here after you check this off. 4.5 kilograms goes down. $8.2 goes on top. Multiply and divide, and you get 12.71. Okay, two more problems I believe for this video. Problem 7, your car uses 13.4 liters of fuel to cover 100 kilometers. Fuel price at the station is set at 1.170 per liter. At these rates, how much does it cost to cover a distance of 145 kilometers? Alright. Oh, let me bring the problem back. There we go. Okay, so for this problem, we are looking to find the distance, and therefore, we are looking to find the cost of the trip, and therefore we use letter C for the cost of the trip in dollars. Now you notice that two relationships are given. 13.4 liters goes with 100 kilometers, and $1.17 goes with 1 liter. In this case, per liter means for 1 liter. So one of our relationships is 13.4 liters, 100 kilometers. And the other relationship is $1.17 goes with 1 liter. Again, the 1 here comes from per. Per liter means for 1 liter. And because we have two relationships, our equation will look like this. We begin with the value that we want to work out, the 145 kilometers, and we write it down on the right hand. My apologies, let me try again. There we go, 145 kilometers. And then we match the unit down here. We need kilometers down here. And if I take a look at all the units that I have in my relationships, only one of them has kilometers. We have liters, kilometers, dollars, liters, and I need kilometers. And therefore it is the first relationship that I will pick. 100 kilometers goes down, matching the unit here, and 13.4 liters goes on top. and therefore our next step is to write these numbers down. Now let's check off equation number 1 or relationship number 1. And now kilometers cancel out and we'll be left with liters. I need to match the unit liters down here. And equation or relationship 1 has been used already and we won't use it again. The second relationship, liters, 1 liter goes down here, matching the unit up here. And $1.17 goes on top. Okay, again, if you want to remind yourself as to how it works, you can do the divisions. Here you get $1.17 per liter, and here you get 0.134 liters per kilometer. So if I know how many liters I need for 1 kilometer, I can multiply by 145 kilometers to find how many liters I need in total. If I know how many liters I need in total and I know the price for 1 liter, I can multiply these to find the total cost of the trip. All right. Now the next problem, and here it is. The next problem says your car uses 13.4 liters of fuel to cover 100 kilometers. Fuel price at the station is set at $1.17 per liter. At these rates, how far can you drive if you have $42.50? Now the previous problem wanted us to find the cost given the distance, and this one wants us to find the distance given the cost. We still note that there are two relationships here. The first one is, of course, 13.4 liters. That goes with 100 kilometers. And the second one is $1.17, goes with 1 liter. All right. Now, we start with the distance that I can cover in kilometers, and because we have two relationships, we will have two divisions. On the right side of the multiplication sign, we put down the number 4250, which is what we want to work out. Then the unit dollars will be matched down here, and there is only 1.17 that has the unit dollar, and therefore 1.17 goes down here and 1 liter goes on top. Now dollars cancel out, we'll be left with liters. Let's check off the equation that we just used. Now I need to match the unit liters down here, and therefore 13.4 liters goes down, 100 kilometers goes on top. Okay, and again, if you want to remind yourself as to how it works, you do the divisions. This one gives you 7.46 kilometers per liter, and this one gives you 0.854 liters per dollar. And now we multiply so many liters per dollar by the total amount of money that we have to find out how many liters we need in total. And if we know how many liters we need and we know how many kilometers for 1 liter, we can multiply those to find the total distance, which is 271 kilometers. Okay, before I finish this video, let me now, in the context of a two relationship problem, to give you an example of what would happen if we followed the other approach to solve this problem. So the alternative for us is now to write down the alternative step-by-step solution, which in step number 1, given the amount of money that I have, I would first find the volume of fuel that I need. And in order to do this, I will set up one equation which is of this form. Division is equal to division. Now, because I want to relate dollars and liters, I would use these two numbers on top and bottom here. Again, it doesn't matter which one goes on top and which one goes down. And therefore, let's say that we put $1.17 on top and 1 liter down. Because we have $42.50 in total, we'll put that on top on the side of dollars, and the volume in liters will go down. Now we do a crisscross, and we get 1.17 times V equals 1 times 42.5. And we simplify, and then divide the right side by 1.17. And we find that we need about 36.3 liters of fuel. Now once we know what volume of fuel we need, then we find out what distance we can cover. And for this we need to move on to step number 2, calculate the distance that I can cover. And here let's say that we put liters on top, or kilometers on top, 100 kilometers on top, and 13.4 liters goes down. And the actual volume that I have is 36.3 liters, and that goes down here on the side of liter. And on top we put down the distance in kilometers. We do a crisscross, simplify, and then divide the right side by 13.4, and we find that I can cover a distance of 271 kilometers. Now you can see that this is a much longer kind of a solution. In the first instance, this is what we had. This is all that we had to do. Keep in mind that the green text doesn't even have to be written down. Let me actually see if I can hunt it down in the code that I have and remove the green. Okay, that should be one of them or both of them. Nice. Okay, so as you can see, in this case, or maybe not, no, there is still one more. There it is. Okay. Let me just get rid of this as well. Okay, let's go back up. Okay, there you go. So you see it's a very short solution. You put down your opening statement, then your equation, final answer, and then closing statement. Now step number 1 that you saw down here, that one actually comes from multiplying these two numbers. This is step number 1. This one finds what volume in liters I need. And then once you work it out, step number 2, which is find the distance that you have covered, all of this work comes from the second multiplication here. So going from here to here, it corresponds to step 1 below, and going from here to here corresponds to step 2 below. I will be making this kind of comparison again in the next video in a bit more detail, but for now it should be sort of like sufficient to show the reader or the listener that the second approach becomes pretty time consuming, and chances of making an error also goes up. Okay everyone, this is the end of this video. In the next one I will cover the topic of conversion of units, and until then, goodbye in 3, 2, and 1.